A ball is thrown upward with a velocity of 96 feet per second. The distance s in feet of the ball from the ground after t seconds is given by s is equal to 96t minus 16t squared. At what time does the ball strike the ground? Let's process the given information through a concept drawing. So here's our ball on the ground, and we're going to throw it up and then it's going to come right back down. The distance of the ball from the ground is given by the variable s. So if our ball is right here, this would be the value of s, and this s function depends on how much time the ball has been in the air. Let's write our s function using functional notation to overemphasize that s depends on time. And just to get a feel for what we get from this equation, let's just notice that at a particular time, let's say t is equal to 1 second, we could plug that time into the distance function and calculate the height of the ball at that time. Here we would get 96 minus 16, and our ball would be 80 feet above the ground. And at this point, I'm not sure whether it would be on the way up or on the way down, but let's just illustrate that on our picture to say that after t is equal to 1 second, the height of the ball above the ground would be 80 feet. So in part A, we're asked, at what time does the ball strike the ground? For the ball to strike the ground, we know two things. Number one, that it's on the ground. And number two, it is when the ball has landed. In order to strike the ground, it's already been up and come back down. And so we're looking for this time. When does this happen? Well, when the ball is on the ground, we know that the position of the ball is 0 because s is the height off the ground. So we'll take s is equal to 0 and plug it in for the height in our height function. So we plug in 0 for s, 96t minus 16t squared, and we solve for t. What we have now is a quadratic equation, and as a matter of fact, this quadratic factors. But before we factor it, let's write it in descending order, and then let's take out the negative 16t common factor. And I'm choosing to take the negative out at this step as well. So negative 16t divided out of negative 16t squared is just going to leave t, and negative 16t divided out of 96t is going to leave minus 6. Now that we have two things multiplied together, we can set each of them equal to 0. So we'll say negative 16t, set that to 0, set the other factor equal to 0. Dividing by negative 16 on both sides here gives us t is equal to 0, and when we add 6 to both sides here, we get t is equal to 6. So we get 2 times at which the position is equal to 0, or 2 times at which the ball is on the ground. And that makes sense with our concept drawing because there are 2 times when the ball is on the ground. One is before we've launched the ball, and then the other is when the ball has landed. And this is the one that we're looking for because we were asked, when does the ball strike the ground? It would strike the ground after 6 seconds. In part B of this question, it asks for what time is the ball more than 128 feet above the ground. Let's bring back our concept drawing to process this question. So we know that the ball is on the ground at t is equal to 0 seconds, and it strikes the ground at t is equal to 6 seconds. But there's some time values at which the position is 128 feet. We need to know when the ball is at 128 feet above the ground and above. Again, here is our position function, and let's translate this statement into math. We want the position to be more than 128 feet above the ground. Well, we know that this is equal to the position. So let's take this equation and substitute it in for position in this inequality. So what we're trying to figure is when is 96t minus 16t squared, which is the position, greater than 128. And what we've just set up is a quadratic inequality. No matter which method we choose, the boundary point method or the graphing method, our first step is to get 0 on one side. I usually choose the direction that gives me a positive leading coefficient. So I'm going to subtract 96t and add 16t squared to both sides. This leaves me with 0 on the left and 16t squared minus 96t plus 128 on the right. Now our numbers in the quadratic expression on the right-hand side are pretty big, but they all divide evenly by 16. So in order to make our computation a little bit easier, I'm going to divide both sides by 16. So we get t squared minus 6t plus 8. And that looks a lot easier to work with. Now, if we're using the boundary point method, the next thing that we want to do is we want to find the zeros of the quadratic. The zeros of the quadratic are the values that cause that quadratic to be equal to 0. So we would take the quadratic, set it equal to 0, and solve for t. Now that my numbers are smaller, it's a lot easier to see that this actually does factor into t minus 4 times t plus 2 is equal to 0. So I get t is equal to 4 and t is equal to 2. So these two quantities are my boundary points. The next thing that we'll want to do is to plot the boundary points on a number line and then test the intervals around them. So we'll plot time is equal to 2 and time is equal to 4 on the number line, and we plug those boundary points back into the original inequality. Now we want to choose values inside the intervals that are as easy as possible, so I'm going to choose as our first test point t is equal to 0. When t is equal to 0, we have 0 on the left-hand side, 128 on the right-hand side, and this is not true. And back at our concept drawing, that makes sense because at t is equal to 0, the ball is still on the ground. It's certainly not above 128 feet. So this interval does not work. Now let's test a value inside the interval, and we'll test t is equal to 3. And again, our test value is being plugged back into the original inequality. So we have 96 times 3 minus 16(3) squared. And we want to know, is this greater than 128? 96 times 3 is 288. 16 times 9 is 144. 288 minus 144 is positive 144, and that is greater than 128. So this interval does work because our test value works. Now let's choose a test representative in this interval, and let's say t is equal to 5. Remember that the ball strikes the ground after 6 seconds, so we definitely don't want to test anything past 6. Again, our test value is plugged back into the original inequality, so we'll get 96 times 5 minus 16 times 5 squared, and we want to determine whether or not this is greater than 128. 96 times 5 is 480. 16 times 25 is 400. 480 minus 400 is positive 80, and that is not greater than 128. So this is not true, and this interval does not work. So the last thing we want to do in the boundary point method is to test the boundary points themselves. But when we do that, we see that at time is equal to 2 and time is equal to 4, these are the values that cause the position to be equal to 128. So 96 times 2 minus 16 times 2 squared is not greater than 128, it's equal to 128. And the same is true for time is equal to 4. But the question asks for when the ball is more than 128 feet above the ground, not equal to 128 feet, so our boundary points would not be included in the solution. So our solution is that the ball is more than 128 feet above the ground between the times 2 seconds and 4 seconds, but not including.